Thank you, Jay. I am super excited in the capacity of both a double Hokie, not a current student, as somebody accused me of being yesterday at the career fair, which was a super high compliment, but a double Hokie, a member of the Executive Advisory Board, and a proud Norfolk Southern thoroughbred, as we refer to ourselves, to introduce our opening keynote speaker, my friend and colleague, Mabby Amouie. Mabby is the Senior Director of Analytics and also the Chief Data Scientist for Norfolk Southern. You may not know that railroads have Chief Data Scientists. I think we might be the first and only to actually have that position. And Mabby has been within us for 8 years. He's responsible for artificial intelligence, data science, and data engineering. He works closely with a lot of departments, including my own, to formulate solutions to real business problems. He uses AI and machine learning, among other things, to bring human-like intelligence to our processes so that we can digitize the railroad for the benefits of safety, operations, efficiency, and productivity. And I will tell you, Mabby is referred to in many conversations with many departments, Mabby and his team. When we get something that we don't know how to solve, we say, could we give this to Mabby and his team? So he is a real trailblazer at our company. In fact, he has grown his department from 0 to 24 since he's been here. He is singularly responsible for introducing data science to our company, and he now leads the team. And that's a pretty tall feat for just 8 years. He has his master's from Northern Illinois, and he has a really cool story, which I'm hoping he'll share with us about an almost PhD and an incredible opportunity to work for a railroad. So it's really my pleasure to introduce Mabby Amouie to the stadium, or to the stand. Come on, go Hokies! I'm always thinking about a stadium.
Wow, well, thanks for having me. Thanks, everybody. I'm thrilled to be here and talk to you about Norfolk Southern. Some of you guys may know us, some of you guys may not. And I'm hoping that by the end of this presentation, you know us way more. And also to talk about how we're using artificial intelligence, data science, and machine learning to fundamentally transform how we operate, as Megan said. The story behind me is not that exciting, but thanks for talking it up. Yeah, the story is that I was finishing up my master's and I had a PhD with full scholarship from the University of Illinois at Urbana-Champaign, UIUC. I was interning at Norfolk Southern. I had my place already figured out. I packed my car, everything's ready to go, and I'm leaving the next day. And very last minute, my boss at the time comes to me and says, hey, we want you to have this opportunity of developing data science at Norfolk Southern. And it was very last minute. Like I said, I had booked everything, and I was going the next day. And I said, well, can I think about it? And the response was, sure, we'll give you a couple of hours to think about it. And I was like, well, 5 years in this and a couple of hours to think about it. Okay, well, fast forward, here I am. I guess I thought about it at the time, and I joined the industry at Norfolk Southern. And we've done quite a bit of things since. And this is a great opportunity for me to talk to you all about how you can make the data actionable in real life. And how a lot of folks say, well, the stuff that you learned in the schools are not applicable. You're never going to use them in life. And this is a true witness here, right here, that they're quite applicable, and you can fundamentally transform how certain industries operate, especially with data analytics that just spans across multiple industries. There's not a single one that you cannot use data and analytics for. So with that, let's get into the actual presentation. Let's talk about Norfolk Southern. We are one of the largest freight railroads in the United States. Our network spans over 22 states, as you can see in this map. We operate predominantly on the east side of the United States. And we move just about everything, which is why when people ask me, what does Norfolk Southern do? I say we move the US economy. Everything from raw material to finished products. Lumber, steel, ethanol, all the way to UPS packages, appliances, BMWs, even equipment for the Department of Defense. The fun fact is that 1 out of every 5 car that you see on the road in the States has been touched by a Norfolk Southern train at some point in its life, either in form of a shipment of the car itself or in form of the shipment of some of the parts that made up of that car. And our network actually reaches out to more than half of the US population. The other fun fact about us is that we are pretty green and sustainable. We can move 1 ton of goods for 450 miles on a single gallon of diesel. That's about a 450 mpg. And by comparison, a very cool Honda Accord has a 40 mpg, so that's about a 10x or 12x difference, and it's only getting better with technology. So we are pretty sustainable, and as we say, we are in the business of building a better planet. But how do we do all these things? Well, we run trains, as you can imagine. Trains that are locomotives chained with a lot of cars that move and transport these goods from point A to point B. And we run hundreds of them on a daily basis. And as you can think about it, we are susceptible to operations disruptions. You know, our locomotives are just like the cars. They can go through mechanical issues. And we also are susceptible to all kinds of weather issues, floods, and natural phenomena, wildfires on the West Coast. So all kinds of things. So a lot of susceptibility to operation disruption. The other fun fact about us that a lot of people don't know, they look at the railroad tracks and they say, oh, this is owned and maintained by Department of Transportation or Federal Railroad Administration even. But the fun fact is that we own and operate 28,000 miles of network. We maintain every piece of it, and it's all across that map that I showed you. Just think about how asset intensive that is, and just think about how much planning and maintenance we need to do on a yearly basis. In fact, we spend $1 billion every year, every single year, to maintain our tracks and roadbeds to ensure that we have a safe and reliable operation. So it's very asset intensive. And then the last one is that we are a large network of connected yards and terminals and depots. And when you think about that, just the intrinsic nature of a network is where you have a problem on one side of the network due to that all connections and jointed behavior of a network, it can very much so snowball and very fast adversely impact another part of the network. So there's a ripple behavior that is intrinsic to any kind of network, and we are not excluded from that. So all these things that you heard here, the susceptibility to operation disruption, and being able to plan and maintain 28,000 miles of track on the top of the fact that you want to minimize network disruptions, how do we do all of that? With data, with analytics, with AI, and among many other things. Which is why about a few years ago, we launched Digital NS. Digital NS is our mission to fundamentally transform the railroad industry and accelerate digital transformation. You know, a lot of us talk among ourselves, is Tesla a car company? Or is Tesla a tech company that also happens to make cars? I mean, a lot of people think of Ford that way too. It used to be a car company, but nowadays it's all technology. It's all data that is also making cars and is running. So we want to think ourselves eventually as a tech company that runs trains as well, because of all the problems that I mentioned to you guys, and because of how much we can harness technology and data, among others, to be able to stay ahead of those problems. And today for you, I have 3 concrete examples. And of course, we are very short with time. I'm not going to be able to dive into them very deep, but I can show you in real life how Norfolk Southern is using all this data to be able to maximize the operations efficiency and stay ahead of all those problems that I talked about. But you might wonder, where is the railroad getting their data from in the first place? Because with Tesla, people are driving and all kinds of sensors and equipment. Don't you guys just run locomotives and a bunch of steel dumb cars at the end of the day? And that's a fair question. but let's get into that. We own about 3,000 locomotives that run our trains. They're about $2 million each, and they're quite complex pieces of machinery. They are as intelligent, I would argue, as a Tesla is today, because they have the capability of transmitting 350 plus diagnostic sensor elements about their engines and all kinds of electrical systems, and you name it. So every second that passes by, all of these 3,000 locomotives are transmitting their water pressure, their oil temperature, their rotation speed of the engine, their fuel levels, and all kinds of things to the back office in real time. And all of that is happening literally every second, and it's coming back to the back office. That's terabytes and terabytes of data. So the question becomes, well, you said that locomotives are susceptible to mechanical failures just like cars are. Can we do something about it? Can we use this data in action to be able to predict and prevent those events? And that's exactly what we started doing. And I'm going to share one of the success stories that we've had with it. There we go. So the context that I'm going to share with you is about locomotive predictive maintenance. About a few years ago, our mechanical department came to us and they said, and here we are, by the way, a bunch of math guys or business analytics guys that don't know anything or anything at all about locomotives and mechanical failures. So they come to us and they say, hey, we got this problem. Locomotives have a radiator just like your cars do. And the radiator has water that cools down the engine oil because as the locomotive is running, the engine can get really hot. And the purpose of this radiator is just to cool it down. So this radiator can have an internal water leak that is completely invisible to us, and it's not anything that we can put sensors or instrumentation around it. As a result of that, the water starts leaking out. There's not going to be sufficient amount of water to cool down the engine oil. The engine can get really, really hot and can start melting its components away. And we're talking about a $2 million locomotive. Well, locomotives are pretty smart. They're not dumb. They shut themselves down. Well, that's great. We prevented a meltdown of an engine. Well, what does that mean to our operation? One thing that I want to share with you guys is that we don't have the luxury of the highways where we have multiple lanes and if something breaks down, you can just certainly pass by. We actually have most of our network, 70% of our network is a single lane of traffic. If something happens, you're stuck. And not only you're stuck, you're going to delay every single train ahead of you and behind you, and the ripple effect starts propagating right there. Something that happens in Chicago can impact something in Virginia. And because of that, well, that smart nature of locomotive is not helping us. It helps us from preventing a loss on the 2 million locomotive, but doesn't help our operation. So we harnessed all of that data. We looked at all the work order data before then, where the crew were saying that, hey, we have this problem that all of a sudden popped up on us. We created AI models to extract the patterns that would lead to that particular breakdown. And we were able to predict those breakdowns on average of 7 days in advance of time with 95% accuracy. If we tell you 100 times that your locomotive is going to break for this reason, 95 times out of those 100 times on average, we're going to be correct about it. And we're going to be within a 7-day window. Well, you're talking to people who are familiar with data but not so much with machine learning. How would they go by trusting you? So we tested it quite, fairly in using backtesting and stuff in our lab, but we went to them and said, don't trust us, because what if we're just telling you that we're predicting something that doesn't happen? Operation as normal. Do what you do every day. If we tell you something's going to break, if it breaks, yay. If it doesn't, well, we failed. We're going to go back to our research lab and work some more. So they said, let's do that. First week, multiple locomotives came true. Next week came true, to the point that their locomotive shops were coming to us and saying, can we operationalize this? Because every time you tell us something's happening, it's going to happen, and we do not want to deal with the consequences of it. So they were the ones that were asking us and pushing us, can we operationalize this? And we did it, and we did it in an automated fashion. Today, that diagram that you see over there, our locomotives are streaming this data in real time. And it's coming to the back office, an AI engine is running on it. It's finding those patterns. As soon as it observes the pattern, it automatically issues a notification and puts a work order against that locomotive for the shops, for everybody in the system to know. And imagine how much flexibility that gives us. You went from a locomotive that's shut down in the middle of nowhere and the snowball impact and effect that's having for our network, to now, hey, I have this crystal ball about the future that I can tell you what's going to happen. I'm not going to put that locomotive on a high priority train, and as soon as possible, I'm going to get it to a shop to get it fixed. So we went from not having any idea about the future to now being able to predict the future. And everybody says, is it a crystal ball? I'm like, yeah, it's a crystal ball called data. And that's the power of data right there. It has been significant impact, a positive impact on our operations since 2018. It's been in production. So let me talk to you about a completely different case now. This rail car that you see looks pretty rigid, and yeah, it's cool, it's red. But this rail car is equipped with lots of sensors underneath it that you can't see, even cameras. It can run on our tracks on those 28,000 miles that I was talking about. And as they're traversing through the tracks, they can gather up to hundreds of different measurements about every single foot of the rail that it goes through it. And this is what we use, the data that we use, to stay ahead of that planning that I talked to you about. You know, just overseeing 28,000 miles of network everywhere, even in the middle of nowhere, it's not that easy. So you need to have a way to do it, and that way is data. And let me talk to you about one of the very impactful use cases that we did to be able to use that for planning and staying ahead of certain phenomena. And that was rail wear prediction. Well, what is rail wear? You know, the rail that you see in the kind of like bottom right and the top portion of it, the yellow portion, that portion is gone over time. Because the rails are metal and the wheels of the cars are metal, metal over metal, it shaves it over time. So the more we run traffic, the more this rail is just like, you know, getting shaved off, and the pieces just come off. So these track geometry cars that I showed you that are equipped with sensor, they can measure the rail every single time that they pass through it. And we inspect our rails multiple times a year. So the diagram that you see over there, that's not drawn up to scale, but you can see the measurements. In April of 2019, we measured that, and the rail, you know, the rail height was there, and then the rail got chipped away some more. So May 2020, you know, it's just like, you know, kind of moving its, you know, moving down until it hits a threshold where we need to go replace it. And that's the last place that you want to be, because replacing a rail is not an easy task. It needs a lot of planning. And as I said, it could be in a very remote location. The rails are heavy and long. I mean, how are you going to transport it without proper planning? So where you want to be is to stay ahead of that threshold and not wait for it. And that is exactly what we did. We gathered all this terabytes of inspection data over time. Every time it was telling us where it is. And we created a predictive model that can predict well into the future, 5 years into the future, where that rail is going to be, considering all the factors that can impact the amount of wear, such as weather patterns, the amount of traffic that goes on it, where it is, the geography and the topography. And I'm going to show you one example of it. Let me break this down for you because it's quite busy. This is, on the x-axis, you're looking at one section of the rail out of this 28,000 miles of network. And every line that you see, it's basically a measurement in the history that we gathered from this piece of rail. And you can see these lines are going down because natural phenomena. You're running traffic, it's shaving off that rail. So it's like shaving away and it's going down. The two black lines that you see, they're not another inspection data. They're actually the prediction out of an AI model, out of a machine learning model that has observed this pattern. It understands the speed of it. It understands whether this pattern is accelerating or decelerating over time. And it is predicting that January of 2024 is when you need to go and replace this rail. And imagine, this is only for 840 feet of our rail out of the 28,000 miles of track. We have this for every single bit of our network. Imagine now the planning power that you have. Because again, you have foresight about the future, something that a lot of people think it's impossible, but it is actually possible. So now we can plan where we are going to replace rail. So we're going to replace the rail at the right location, at the right time, and we're going to stay ahead of all this planning and crazy things that can go on. So imagine what the power of AI is. So let me talk about one last one. And this one is my favorite because it has a lot of visuals, and it's kind of cool. Digital train inspection using high-speed cameras. Well, let me first talk to you about the train inspection. Railroads have been around for quite some time. For decades, if not a century, the train inspection has been done one way, you might imagine. Trains are 3 to 5 miles long. We start with 2 people on both sides of the train, walking along this train, literally walking for 3 to 5 miles. And at every rail car, looking at it visually, assessing it for 350 different defects that can go on. Oh, this handle is broken, this bolt is coming loose, and this bolt is even missing. 350 plus defects. And so many rail cars, 3 to 5 mile long, you need to walk it. Doesn't matter if it's snowing or low visibility or whatnot. It takes them 2 to 3 hours to complete this. And this has been going on for decades, if not a century. And that's the way to inspect trains. That's the way to ensure that we have, safe trains, because you don't want to have a defect that's going to cause an incident for you. You want to find it and you want to fix it. But as you can imagine, there are human vulnerabilities here. We are not perfect. We don't have laser eyes. If there is low visibility in Chicago, heavy snow, there's naturally a probability that we're going to miss one of these defects. Now, some of those defects that are being missed are maintenance type item, not important, even if it's missed, but some of them can result in a train incident because it was a substantial defect that got missed. But again, human vulnerabilities and variation. Let's see how we can fix this, how we can fundamentally transform something that's been done for almost a century with data. So we have high-speed cameras. We call them machine vision detectors. They're basically high-speed cameras. As the trains are passing by at up to 70 miles per hour, they can image our trains and every rail car from different angles. And all these images that you see here were taken at 70 miles per hour, or 60 miles per hour in this case. And we have deployed these things in multiple parts of our network. Well, this is great because it's the same concept as your traffic cameras that are reading the license plate and all. So can we do this? Can we run our trains by these cameras, get these images, and have those people who are walking, sitting by the computer and going through the images? That's a great idea to some extent because we're getting a ton of images, thousands and thousands, if not millions of them on a daily basis because we run a lot of trains, and trains are 3 to 5 miles long. So you need an army of people in the back office to scroll next through the images. I mean, if I see 100 images, the next one, I'm probably not going to have the same attention that I had when I started. So you're going to have the same vulnerability and the same problem on the top of having an army of people that need to sit in the back office. So you solve the problem, but you band-aided it. Well, how can we leverage machine learning and deep learning to change this? Let's look at it. This is, by the way, the blown-up images of it. You can see even the picture of underneath, on the top right. If you want to have that view today, there's one way to do it. You need to literally crawl underneath the train for 5 miles. Who's up for challenge? 5 miles. So imagine that. So we got all these different images. We talked to our folks, to our mechanical folks. What kind of defects are those 350 ones? What are the top defects that we can go after? Can we train an AI model that would do this for us, that would get human intelligence to the level that if it looks at an image, it can find that defect for us, similar to what a human would do? Is that even possible, or is that like a long shot? Well, when you have self-driving cars right now in San Francisco, Cruise and Waymo running around with nobody in it, every millisecond they're making an assessment of the traffic signs. Oh, I see a traffic sign. I see a pedestrian. They're analyzing those pictures and videos the same way, right? And that's the technology, a similar technology what we're using, similar deep learning models that Tesla and Cruise are open sourcing. So we used it, we modified it, we morphed it for our own problem to be able to detect these defects automatically using AI as these images are coming. And the success has been phenomenal. We're finding defects, in fact, at rates that are orders of magnitude more than humans. That is not because we're not doing a good job as railroad all around the globe. It's just because you have human vulnerability in tough conditions out there in the field. And it's just because AI is not tired of looking at all the images next. And I'm going to show you some of those examples. But before that, we deployed these at the edge. And what do I mean by that? So sometimes the volume of data is so much, in this case, all these images that get generated from these trains, that it just doesn't make sense to ship it all back to, in our case, our headquarters in Atlanta, and then have this computer models look at it. Instead, we take our servers and algorithms right by where the data gets generated. So we have these cameras in very remote locations. Train passes by, images get generated. We have servers right there that will look through this particular set of data that got generated, find the defects, and only send the picture of the defect and not everything else. And as you can imagine, most of the pictures are pretty okay, and only a few are defective. So that's the concept of edge computing, and I'm going to show you a flow of it. That's what we did in this case. But before then, let me show you some of those defects that are getting detected by AI in action. These are some of the defects, and I'm going to break them apart for you because nobody here is a mechanical expert for a train. But let me talk to you first about the bottom left one, the one that has the blue color and red color. Those pipes that you see, they're called air hoses, and they are part of the braking system of a train. If these braking system, if these pipes come apart, the train goes in a state of emergency and needs to stop. The conductor or engineer need to come out, walk along a 5-mile train anywhere, and figure out where it even happened, because there's no sensor or instrumentation to do so. So it's very important for these to stay intact. Now, if these things are hanging too low, there's a very good possibility that they're going to hit something on the track, and they bust, and they come apart. So it's very important for them to be high up the ground from the track. What AI is doing in this case, it's understanding what the air hose is in this image. I mean, I have a very complicated image of the locomotive here. It's understanding out of all those things where air hoses are, taking it the next step, which ones are dangling and which ones are connected. The red ones are connected and the blue ones are dangling. And then ultimately, it's computing its lowest point, the distance of it to the top of the rail, to say, how low is it hanging? And if it's too low, I need to send a notification and say, hey, you got to go and inspect this particular rail car. And all of this is happening at 60 miles per hour within milliseconds without any human action or any human involvement. And the intelligence of AI to be able to even understand this picture and understand its components. I did not get a paintbrush, by the way, in Microsoft Paint. And by the way, Microsoft Paint is going away anyways, which is my favorite tool. But I did not get a paintbrush to go and paint this red and blue. This is all the output of the AI system. So that's crazy, but that's achievable in 2022 with the power of data, with everything that you guys are going through and studying. And I'm going to also talk about the right one. That is underneath a car. And as I said, if you want to have that view, you need to crawl underneath. You can see the bolts are getting detected with green, and the one that is missing, the hole, is red. If those bolts come undone, that plate's going to fall. That car is going to basically cause an incident. Train incidents are anything from nothing, depending on the train dynamic, to a derailment, to something that could be pretty catastrophic. AI is finding that missing bolt well in advance as this is passing by, the train is passing by, sending notification in real time saying, hey, you got to go inspect this particular one, and you got to do it immediately. And that's where the human action comes to the picture. We go and do it. So that's the type of defects that AI is detecting, all in real time. Let me talk to you about the pipeline of it, and then I have a couple of slides to wrap this up. It all starts from the left side. There's a hardware component. These cameras, these detectors, high-speed cameras. Train passes by. In real time, all these images get generated. The AI engine, the models that we're training, they are running right there at the edge, looking at all these images, multitude of them as they're coming, terabytes of them, finding defects, sending it back to our operations center. We have it, we run a 24/7/365 business. That's just how railroads operate, every day, every minute. So we have a 24/7 operation desk that they get these alerts, and they correspondingly take action. Actions that include even talking to that train and saying, hey, bring it to a safe stop immediately. Let me fix this problem, and then let it go, because it's unsafe to do otherwise. It's unsafe to keep that train going. And all of that is happening in real time. It's crazy. Where are we taking this? I started by saying 350 defects. And of course, we have only so much capacity to create and train these AI algorithms. So we started with top defects, and we are just crunching through the list. We have tens of algorithms right now. And we're also creating more and more and more algorithms that will look at these images and assess them for different kinds of defects that we don't have today. And we're also putting these camera solutions in 16 different corridors on our network that will cover 95% of our traffic. In other words, 95% of our trains, as they're going daily, will pass one of these sites one way or another. So as they're passing by, automatically they get inspected. No human involvement whatsoever. And better inspection quality. This is not to replace human. This is to augment the capability of the human. This is to turn the finders of those defects to now go fix them, because that's where the productivity is. It's not for you to find these defects. It's for you to know, to have a sheet of these are the defects on these cars, and then let me go fix it. And that's why our people love it. So I'm going to wrap it up by the benefits, and I'm going to be a little bit more general here, but let's first talk about the benefits of this particular project. Reduction of train incidents, it's just self-explanatory. As we are finding these defects, orders of magnitude more than humans are doing, we are preventing potential incidents, potential defects, and we're preventing them, we're finding them and fixing them before they become an issue. And you have increased frequency of inspection, because as these trains are passing by, they're getting just naturally inspected without us doing anything. So we have an improved detection rate, as you can see, and we are reducing train delays. All these incidents ultimately, I failed to mention it, it's ultimately to run a fluid network, to prevent all those incidents that could happen, that could then snowball, that could then impact your service product. Because for our customers, what matters is that your train's got to be on time, and you need to give me the shipment on time. And all this is what is ensuring that, or at least the steps to ensure that our quality of the service product goes to another level. And finally, again, as I said, we're going to have less yard dwells, because in the yard, everybody's like running 2 to 3 hours to just inspect these trains. All of that will be gone. You're just fixing it. So, and ultimately, you're improving our service product. So I want to close by saying that all of these that I showed you were real examples of what data and what data analytics can do. It's a fundamentally innovative solution for 2022 and for the next decade, because using the power of data and using the power of machine learning and data analytics, you can apply these to any kind of industry, in any industry possible. Doesn't matter if you love railroad or not. You can do this in healthcare, to do x-rays and find brain tumor from an x-ray. You can do this anywhere. You can do it in the self-driving car industry. So the application of AI and data is just, it's limitless. So what you guys are doing, you guys are on the right track for changing the world with one of the most powerful technologies that has gotten introduced, and it's only getting better and better. I'm in the field myself, and every day I'm amazed by the new models that are coming and how powerful they are and how different they are. I talked to Siri. 10 years ago, it was unscripted. You would ask them something, and they would just respond something very transcribed. Right now, Siri knows me better than my mom. I guarantee you that, because it has gone through all my web pages and surfs and everything. So anyways, you guys are on a great path, and everything that you're doing is 100% applicable in this industry. Don't let anybody tell you otherwise, because that's the bad advice that I got at some point, that everything that you're reading here, it's not going to be applicable. It's quite the opposite. It's 100% applicable. It's 110% applicable. So with that, thank you so much. Thanks for having me, and wish you all the best.